In this video, we'll take a look at section 7.1, angles. This is our introduction to trigonometry. So a review of angles from geometry. There's an acute angle. I'll get to standard position in a second, but there's an acute angle. It's between 0 and 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180 degrees. And a 180 degree angle is a straight angle or half a rotation. So if an angle is in standard position, we're taking our angles and putting them on the coordinate plane. The vertex is at the origin. The initial side is along the positive x-axis, and we rotate counterclockwise for positive. So counterclockwise is a positive angle. And then where we land is the terminal size. So in this case, alpha is a counterclockwise positive angle. Then a negative angle, the initial side is still along the positive x-axis. We're rotating clockwise, so our angle is negative. We still have the vertex at the origin, and the terminal side lands here. So clockwise is a negative angle. So if we take a look at some of the angles in standard position, since we define an angle in standard position by its terminal side, we have a special type of angle whose terminal side lies on an axis. They're called quadrantal angles. So this type of angle can have a measure of 0 degrees, it can have a measure of 90 degrees, 180 degrees, 270 degrees, or if you go all the way around, 360 degrees, and that would be the same as 0. So if the angles are along, the terminal side is along the x or y axis, it's called a quadrantal angle. So let's take a look at some examples of drawing and labeling angles in standard position. So these are in degrees, so we know that our start is 0 or 360 degrees, 90 degrees, 180, and 270. So 120 degrees has to be between 90 and 180. So there's our initial side, terminal side, and there's the 120 degree angle. So there's drawing it in standard position. Negative 25 degrees goes the negative direction, so we're rotating counterclockwise or clockwise. So if we rotate 25 this direction, that's negative 25 degrees. The terminal side is 25 degrees rotated clockwise. The third angle, 400 degrees, goes, I'll draw that on a separate, goes around once, so 360 degrees is one full rotation. So 400 minus 360 is 40 degrees, so there's another 40 degrees, so it lands in the first quadrant. So that angle of 400 degrees is one full revolution plus another 40 degrees. So degrees are only one way to label angles. We also have a measure called radian. The radian measure, the advantage to that is it's a real number. A degree means we're taking a circle and cutting it into 360 pieces. A radian is measuring in real numbers. So what is a radian? So 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So what that means is, if you have a length of radius from the center to a point on the circle, if this arc is also r, then the angle measure is 1 radian. So we can convert back and forth in between, okay? And before we do that, let's label the circle in our radians. So our quadrantal angles this time, we still have 0 radians. Radians don't have a unit of measure since they're real numbers. Halfway around the circle is pi. So circumference, if you remember, of a circle is 2 times pi times the radius. Okay, so the radius is 1, then 2 pi is 1 revolution around the circle. So when we get back to the beginning, 0 and 2 pi and land in the same place. So if pi is halfway around, then a quarter is pi divided by 2. So there's 0, pi divided by 2, pi, add another pi over 2. This is 3 pi over 2. So those are the measures in radians. So if we want to graph our angles, draw and label, if our angle is negative pi over 4, then we're going to rotate in the negative direction. Pi over 4 is a quarter of the way, so half of the way between, or a quarter of the way between 0 and pi. So a quarter of the way would be here. So this is rotating. I'll label out here, negative pi over 4. So we've rotated clockwise. The next 3 pi over 4 is 3/4 of the way between 0 and pi. So 3/4 of the way would be here. So that's 3 pi over 4. Negative 7 pi over 4. Let's see, 8 pi over 4 would be 2 pi. So if we're going negative 7 pi over 4, you can also think about it in quarters. We're going negative 1, 2, 3, 4, 5, 6, 7 quarters. So if we're rotating backwards, this one is negative 7 pi over 4. And then last, 13 pi over 4, that's greater than 2 pi. So if we go around the circle once, that's 2 pi, or 8 pi over 4. So 13 pi over 4 minus 8, we're left with 5 pi over 4. So we're rotating around the circle once, and then another 5 pi over 4. So there's 1, 2, 3, 4, 5 quarters. We end up here. So that would be 13 pi over 4. So we've rotated counterclockwise, a full rotation plus another 5 pi over 4. It's hard to get used to radian measure, but that's what we're going to use we'll go back and forth between radians and degrees. All right, so if you notice, we're rotating around the circle a few times. We also, next topic that we want to talk about is converting between degrees and radians. So we're going to use the basic relationship that pi radians is equal to 180 degrees. So if we want to convert degrees to radians, multiply the degrees by pi radians over 180 degrees. So if we want to convert 60 degrees, we take 60 degrees times pi radians over 180 degrees. So 60 degrees goes into 180 3 times. So that ends up being pi over 3 radians. B, 270 degrees. We looked at that on the unit circle, or on the circle. 270 times pi over 180 is equal to 3 pi over 2. And then negative 300 times pi over 180 degrees. We get, cancel your fraction. Let's see, the zeros cancel. 30 over 18 would be the same as, let's see, 6 goes into both. So that would be negative 5 pi over 3. So that's converting degrees to radians. If we want to go the other direction, radians to degrees, multiply the radians by 180 degrees over pi radians. So pi over 4 times 180 over pi. The pi's cancel. 180 divided by 4 is 45 degrees. B, you can also, if you have pi, you could also substitute 180 in for pi. We have negative 4 pi over 3 times 180 over pi. The pi's cancel. 3 goes into 180 60 times. 4 times 6 is 24, so we have a negative 240 degrees. And then last, 6 radians we would have 6 times 180 over pi. And we get 6 times 180. Let me do that on the calculator real quick. Is 1080 over pi degrees. And if you want to need that to the nearest tenth, that's approximately 343.8 degrees. So we can convert back and forth between radians and degrees. So there's some angles that are commonly used in both degrees and radians, and we'll see these throughout the next few sections. So angles 0 or 2 pi, 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2, and then notice the symmetry. We're going directly across to 120 degrees, 2 pi over 3, 135 degrees is 3 pi over 4, 150, 180. So kind of keep these in mind. These are angle measures that we're going to look at in the next couple of sections and find trig ratios that go, sine, cosine, tangents that go with them. Okay. All right, so next, coterminal angles. So two or more angles are coterminal if they share the same terminal side. Angles can rotate counterclockwise or clockwise, and adding or subtracting an entire revolution, either 360 degrees or 2 pi radians, results in coterminal angles. So if you remember from the 400-degree angle from before, if you rotate 400 degrees, you go around the circle once. So if we take 400 degrees minus 360, we're left with 40. So an angle that's coterminal with 400 degrees is also 40 degrees. So we want to find a positive angle less than 360 that's coterminal. Okay? So if we kept going around and around, if we wanted another angle that's coterminal that didn't necessarily have to be, we could add 360. So 400 plus 360 is 760 degrees. That's also coterminal. Or we could subtract 360, we could subtract 360 again and get negative 320 degrees. So there are an infinite number of angles that are coterminal. We just keep going around and around the circle, either clockwise, counterclockwise, or clockwise. Okay. So next, if we want to find a positive angle less than 360 coterminal with 135 degrees, 135 degrees negative is rotating clockwise. So we're going to negative 135 lands here. So how far would that be if we rotated in the clockwise or the counterclockwise? So in this case, we're going to take 360 degrees minus 135 degrees. And we end up with 225 degrees. So an angle that's coterminal with negative 135 is a positive 225. And again, we could keep going 360 degrees around each direction. So you can also have your angles in radians. So if we want to find a positive angle less than 2 pi that's coterminal, A, 13 pi over 5 is greater than 2 pi. We're going to subtract 2 pi, 13 pi over 5 minus 2 pi, but we need a common denominator. 2 pi over 1 is equal to 10 pi over 5. So if we take 13 pi minus 10 pi over 5, we get 3 pi over 5. Okay, so think about that as going around the circle once, and then another 3 pi over 5. And you'll end up about here. Then the other, if we want to go negative angle, if we're going to rotate negative pi over 15, then what would that angle be if we rotated positive instead of negative? So in this case, we're going to take 2 pi minus pi over 15. So let's see, 2 pi would be 30 pi over 15 minus pi over 15 is equal to 29 pi over 15. So if we were going to rotate in the positive direction, we would rotate a positive 29 pi over 15. So coterminal means they have the same terminal side. All right, another definition is something called a reference angle. So a reference angle is not the same as a coterminal angle. A reference angle is the smallest acute angle formed by an angle's terminal side in standard position and the horizontal axis. So 400 degrees, we figured out that we rotate around the circle once with another 40 degrees. So the reference angle, this is 400, we've gone around the circle. The reference angle is the smallest acute angle formed by the terminal side and the horizontal axis, so with the x-axis. So the reference angle for 400 degrees is 40 degrees. For 138 degrees, if we're rotating 138 degrees, we land here. It's the smallest angle with the x-axis, so the reference angle is going to be the angle that this makes with the x-axis. So in this case, we're going to have to take 180 degrees minus 138, and we end up with 42 degrees as the reference angle. And then 42 plus 38 is 180. And then part C, negative 10 degrees. If we rotate 10 degrees in the negative direction, the angle, the positive acute angle that makes with the x-axis is 10 degrees. So the reference angle is 10 degrees. So notice that the reference angles are positive. All right, so 4 pi over 5. We have 0, this is pi over 2, this is pi. So we have to think about it in terms of fractions. That's 1/2, 1, 4/5 lands about here. The angle it makes with the x-axis is this one. So we take pi minus 4 pi over 5, and it ends up being pi over 5 as our reference angle. Negative pi over 3, since our rotation is still doesn't reach beyond the fourth quadrant, negative pi over 3 lands about here. So the angle it makes with the x-axis, it's still an acute angle. So pi over 3 is the reference angle. All right, last idea in this section is how do you find a length of an arc on a circle, and how do you find the area of a sector? So remember that the radian was actually defined by a circle with an arc of size of r, okay? So let r be the radius of a circle and theta the non-negative radian measure of the central angle of the circle. So the central angle of the circle is the angle formed by the two radii, okay? The length of the arc intercepted by the central angle, this s, this arc length, is the radius times theta. And theta needs to be measured in radians, okay? So it's radian measure. So an example, a circle has radius 6 inches. So let me draw the circle. It has radius 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees. Well, this angle of 45 degrees is given in degrees, so we need to change that to radians. So 45 degrees times pi over 180 degrees. 45 goes into 184 times, gives us pi over 4. So the arc length is the radius times the angle measure. So our arc length is our radius 6 inches times pi over 4. Let's see, we can cancel our fractions, divide by 2, this is 3, 2. We get 3 pi over 2, and it's measured in inches. So the arc length is 3 pi over 2 inches. The area of a sector, using this same picture, the area of a sector is 1/2 times the angle times r squared. So remember, the area of a circle is pi r squared. So this is derived from the area of a circle using the central angle theta. So to find the area of the sector of the same circle with radius 6 inches and central angle 45 degrees, we use area equal to 1/2 times the angle in radians, pi over 4, times the radius, which is 6, squared. So we're going to end up with 1/2 times pi over 4 times 6 squared is 36. Let's see, 2 goes into 36, 18 times, let's see, 4, 2 will go into 4, 9. I end up with 9 pi over 2 square inches for the sector. So you can find arc length and area of a sector. These would be in exact values. And then if you want to decimal values, take 3 times pi divided by 2 in your calculator. Don't use 3.14, use the pi key. So 3 pi divided by 2 is approximately 4.71 inches, and 9 pi divided by 2 is approximately 14.14 inches, square inches. So exact values leave in terms of pi or square roots, and then decimal, go ahead and use the pi key.